Okay, so today we'll be talking about with partial fractions. What we'll be doing is we'll be doing integration with with the use of partial fractions to really help break down a problem, make it a lot easier to work with. Now, partial fractions are the idea that comes from the fact of, like, for example, 1/2 plus, let's go 2/3. That turns into 3/6 plus 4/6. Why am I not thinking of this very clearly? Which equals 7/6. Okay, so normally we are used to going this way where we add fractions and we get there. Partial fractions is you go from here to here and use a method like this. For example, let's say we had, let me see. Okay, so basically breaking up a fraction like this, 6 over x squared minus 1 into a over x plus 1 plus b over x minus 1. A and b are some arbitrary constants that we don't know about. Okay, the really cool thing is that you can actually set this up, and you probably already learned this in trig, but basically you can set up the problem so that it looks like this. 6 equals a times x minus 1 plus b times x plus 1. Okay, now where we got these from here to here is basically we got a common denominator between these two. We added them together, and since they're two fractions equal to each other, then the numerators have to be equal. So that's where we got that from. Now, the best part about doing this is that you can actually figure out one possible combination just to work with this. Okay, and that combination is basically the number that cancels this out to 0. So, for example, to find b, I would plug in x equals 1. So 6 would equal 2b. Okay, and thusly 3 equals b. Okay, and see how it cancels out this one. And then to find a, I would plug in x equals -1. Okay, so 6 equals -2a, right? So -3 equals a. Okay, and that would be the two possible solutions that I could work with. So -3 right here and 3 right here. So that's where partial fractions came from. Okay, but what we're doing today is we're going to be doing partial fractions integration. Okay. So something would look like this: the integral of 1 over x squared minus 4 dx. Okay, so the first thing we would do is we would probably break it up into its factors. So this is a difference of perfect squares, so it's x minus 2, x plus 2. Okay, so you are going to have two partial fractions. So when we set up the next part, it should be a times x minus 2 plus b times x plus 2 equals 1. And then you could quickly figure out how to get down to the other parts. So you could do like, x would be 2 here, so 2 here, so 4b equals that. So we would end up getting b equal to 1/4, and then c would be equal to -1/4. Okay. All right. Now all you have to do is just plug that back into these two spots right here. I would probably factor it out so that it would look something like this. Okay, so it would look something like this, and I just realized as I was typing in those equations that this turned from a C to an A because basically I made a mistake of messing up the part where it actually gets to be there. So that should have been an A, by the way. Okay, so what I did was I factored out the -1/4, so I'm left with this, and all I need to do is do some natural logs because I'm doing the integration of some fractions, and it should look like this. Ta-da! It should look like something like this: -1/4 times the natural log of x plus 2, or natural log of the absolute value of x plus 2 plus 1/4 times the natural log of the absolute value of x minus 2 plus our arbitrary constant. Okay, And once again, if you got lost on how we got to be these numbers, think of what 0, cancel these out to be 0, and then solve for the other letter, and that's the best way to actually do it. Okay? All right. Thank you very much. That's been Partial Fractions. I'll talk to you later. Bye.